So here we need to verify that the given sequence is a harmonic progression. And also we need to determine its 13th term. So let us begin. Now, in order to show that the given sequence is in a harmonic progression, what we'll do, we'll take the reciprocal of each term. So let's take the first term. So here the first term is 3 over 2. We take its reciprocal, so that's 2 over 3. Then we take the reciprocal of the second term, that's 1. Reciprocal of the third term will be 4/3, 4 over 3. Then reciprocal of the fourth term will be 5 over 3, and reciprocal of the fifth term will be 2, and so on. So let's show that this particular sequence is an arithmetic progression. What we're trying to do, if we can show that the reciprocal of each term of the given sequence is an arithmetic progression, then definitely this given sequence will be in harmonic progression. So here, let's consider our first term, so that's 2 over 3. And then we have to find out the common difference. So the common difference would be, we'll take the second term and from it subtract the first term. So we have 1 minus 2/3, so this is going to give us 1/3. Similarly, we can take the third term, 4 over 3, and from it subtract the second term. So 4/3 minus 1, so that's going to be equals to 1/3. Let's also check 5 over 3, which is the fourth term, and from it subtract the third term. So that's also going to be 1/3. And also 2 minus 5 over 3 is also going to be 1/3. So that means we have a common difference with a value of 1/3. This means that this particular sequence is an arithmetic progression. Now, because it's an arithmetic progression, so it must be true that its reciprocal of each term must be a harmonic progression. This implies that 3 over 2, 1, 3 over 4, 3 over 5, half is a harmonic progression. So this must be true. Fine. Now to find out the 13th term of the harmonic progression, let's first find out the 13th term of the arithmetic progression. The 13th term of the arithmetic progression, so that will be a plus 13 minus 1 times the common difference d. So what's the first term? That's 2 over 3. So here we have to consider the arithmetic progression, since we are trying to find out the 13th term of the arithmetic progression. We have 2/3 added to 13 minus 1, that's 12. 12 multiplied to d value is 1 over 3. So 2/3 plus this is going to be 4. So 2/3 plus 4 is going to be 14 over 3. So this is the 13th term of the AP, which means that therefore the 13th term of the harmonic progression, so that will be the reciprocal of the 13th term of the AP, so that's 3 over 14. So that is the 13th term.